Hi, this is the homework assignment that I'm giving you for this week. I'll explain some of these questions. The first question says, what are the mean, median, and mode of this set of numbers? I just want you to find the mean, median, and mode. You can just use a basic calculator. To get the mean, you just add up the numbers and then divide the total by the number of numbers. To get the median, you put the numbers in order first, and then you either take the middle number. If I gave you an odd number of numbers, like 7 numbers, or you take the two middle numbers and calculate the average of the two middle numbers. If I gave you an even number of numbers, like 4 numbers or 6 numbers. And the mode is just the number that appears the largest number of times. When you calculate the mean, it'll come out, you'll have decimals in your answer. You can just round your answer to 1 decimal place. So I'll actually have you round all of your answers that have decimals to 1 decimal place. So if you get 2.674, you would round the 6 up to 7, because 7 is 5 or higher. When this digit right here in the hundredths place, you round up when it is 5 or higher, or between 5 and 9, and you round down when it is between 1 and 4. So this number 7 is between 5 and 9, which would mean that the 6 would be rounded up right here. The 6 would be rounded up to 7, so the answer would just be 2.7. If we had something like, well, if your answer came out to 2.631, 3 is between 1 and 4, so you would round down, and your answer would just be 2.6. And for all of these questions that involve calculations, just show all of your work on paper, show all the steps that you did on paper, and then just staple your work to the back of the homework assignment. This next question asks, if I asked 7 people to tell me their age groups and their answer, and these were their 7 answers, what would the median and mode be? To get the median, you put the answers in order, and you take the middle value, just like you did in question 1, and the mode is just the answer that shows up the largest number of times. You can find the median of these answers because age group is an ordinal variable, which means that you can put the people's answers in order from smallest to largest. Question 3 says, what is the range of these numbers? You don't even need a calculator for this answer. Just find the highest number and find the lowest number, and then subtract the highest number by the lowest number. And also show your work for this question. You can just show it on the same piece of paper that you used for question 1. Just do all of your work on one piece of paper, unless you run out of space, and then you can start a new piece of paper. It says, what are the variance and standard deviation of a population of 7 people who have these ages? Well, if it's a population, you have to use the formula for a population variance and population standard deviation. Notice that the numbers I gave you aren't in order, but they don't have to be in order for you to calculate this. What if we had 10, 14, 16, 12 as a population of 4 people? I'm giving you a population of 7 people and a sample of 4 people. So in this example, I'll do a population of 4 people and a sample of 3 people. Actually, let's see, 7 and 4. Maybe I'll do 8 and 6. So 12, 14, 16, 18, 22, 20, 1, 2, 3, 4, 5, 6, 7. And then we'll use these numbers. To get the variance and standard deviation, first we have to know the mean of these 8 numbers. So let's add them up and divide the total by 8. 10, the total is 136. If we divide that by 8, we get 17. We can just put the mean down here just so we know what it is. You don't have to put the mean down here when you're showing your work. I'm just doing it so we know that the mean is 17. What you need to do is subtract each of these numbers by the mean. So subtract all of them by 17. So what answers do we get? We get negative 7. We get negative 3. We get negative 1. Negative 5. And then these ones will come out positive. Or at least this one will. 1. And then this one is 5. And then 3 and 7. These are our deviations. And next we have to square each of them. In class I said that when you subtract each of the recorded data values by the mean, the answers that you get are called deviations. And before you can get a variance and standard deviation, you have to square all of the deviations that you've calculated. So what do we get if we subtract our first deviation of, what do we get when we square our first deviation of negative 7? We get, well, negative 7 times negative 7 is 49. when you multiply a negative number by a negative number, you get a positive number. I'm also not going to require you to put these titles up here when you show your work. I'm just doing it to help me explain the steps. So these are squared deviations. -3 times -3 is 9. So -3 squared is 9. -1 times -1 is 1. What about -5 squared? Well, -5 times -5 it comes out to the same answer as 5 times 5. It's just 25. And the positive ones are easier. 1 times 1 is 1. When we square each of these positive numbers, we just multiply the number by itself, and it's easy because we don't have to deal with the negative signs. So 5 times 5 is 25, 3 times 3 is 9, and 7 times 7 is 49. Now, I said this was a population of 7 people. No, I mean a population of 8 people. So we would use the population formula. So I'll show you how to do that. First, we have to add up these numbers to get the total of the squared deviations. So the total comes out to 168. That's the total of the squared deviations. Now we average the squared deviations, or we calculate the mean of the squared deviations. How do we do that? Well, we have to divide the total by the number of numbers, in this case by the number of squared deviations. So we have 1, 2, 3, 4, 5, 6, 7, 8 squared deviations, which means we divide the total by 8. Just because we have 8 numbers in this list of numbers right here. So we divide by 8. Comes out to 21. That's our variance. The variance is just what you get when you average the squared deviations. And it's more specifically called a population variance. I said this was a population of 8 people, and that means our answer is called a population variance. If our data was from a sample and not from a whole population, we would actually do something with this number right here that we're dividing by. We would drop it down by 1. So if this was a sample of 8 people, if it was a sample of 8 people from a bigger population, we wouldn't divide by 8. We would actually adjust the formula and divide by 7. We would drop this number down by 1, and the answer would be called a sample variance. So drop this number by 1, or subtract this number by 1 if the data is from a sample. And not from an entire population. And like I said, most of the time data sets do come from samples and not entire populations. So in actual research, this number would almost always be dropped down by 1 because almost all data comes from samples. So we didn't subtract it by 1. We left it as 8 because I said this wasn't an entire population. Now let's do an example with a sample. Instead of having all 8 people, we'll just say that we have a sample of 5 of the 8 people. So maybe 1, 2, 3, 4, 5. We'll take the first 5 answers, or the first 5 people to be the sample of the population. Oh wait, I skipped a step, so I'll get this back. Sorry, I didn't get the standard deviation. If you take the square root of 8, no, the square root of 21, you get the standard deviation. So to get the standard deviation, you just take the variance. To get the standard deviation, you just take the square root of whatever the variance equals. So if the variance is 21, then the standard deviation is just the square root of 21. Standard deviation is the square root of the variance. So the square root of 21 is 4.58. I said it's okay to round it to 1 decimal place, so we would round up to 4.6. And this would be our population standard deviation. Now let's take the sample of 5 out of the 8 people. I'm going to erase these people right here. Since we only have 5 people now and not the whole population, our mean has changed. So we have to average our numbers again. We actually have to start completely over again. So let's find the mean of these 5 numbers. Let's add them up and divide the total by 5. 10 plus 14 plus 16 plus 12 plus 18. 70 divided by 5. The mean is now 14, which means that we're going to subtract each of these numbers by 14. And when we subtract 10 by 14, we get negative 4. 14 minus 14 is 0. 16 minus 14 is 2. 12 minus 14 is negative 2. And 18 minus 4 is 4. Now we have to square each of these deviations. negative 4 times, when you square negative 4, you just multiply negative 4 times negative 4, and that gives you the same answer as 4 times 4. It just comes out to 16. 0 squared is 0 because 0 times 0 equals 0. 2 times 2 is 4. Negative 2 times negative 2 is 4. 4 times 4 is 16. If you ever see a negative sign in your column of squared deviations, it means that you must have made a mistake, because all of these numbers will always be positive. Whenever you square a number, you always get a positive answer. So let's add our squared deviations. This adds up to 20, so this has to be 40. And now we have a sample of 5 people, so we divide by 1 less than 5. We divide by 4, because that's the adjustment you make when your data comes from a sample. When I did an example in class, we had a sample of 3 people. We had 3 numbers, and we divided by 2, because 3 minus 1 equals 2. And I think someone was asking if we would always divide by 2. We wouldn't always divide by 2. If we have a sample of 3 people, we divide by 2 because 2 is 1 less than 3. But if we have a sample of 5 people, we now divide by 4 because 4 is 1 less than 5. So you just divide by 1 less than the number of numbers. 14 divided by 4 is 10. So 10 would be called a sample variance. And there's actually 2 reasons why it's called a sample variance. One reason is because the data was from a sample and not from an entire population. And the other reason is because we did this adjustment right here. We divided by 4 instead of 5. So what if we take the square root of our sample variance? We take the square root of 10. Put the square root key right here. We get 3.16, and you can round that to 3.2. And that becomes the sample standard deviation. So if you take the square root of a population variance, you get a population standard deviation. And if you take the square root of a sample variance, you get a sample standard deviation. So 3.2 is the sample standard deviation. And when you're doing your work on paper, it would be fine to just show your work the same way I did here. Just write out something similar to what I did on this screen right here. It would also be nice if you could show your work for the squaring. If your calculator can square numbers automatically, then you don't have to show your work for the squaring. But if you're actually multiplying numbers like -4 times -4, then it would be good to show those on paper. Let's see. So that takes care of these questions. Question number 6 asks you to write out 2 sets of 5 numbers in order from smallest to largest, and make it so that the second set of numbers has more spread than the first set of numbers. I just want the second set of numbers to be more spread out. So look back at you could look back at the PowerPoints where I have one slide that says this set of numbers has the lowest spread, this one has the middle amount of spread, and this one has the highest spread. And just create two examples like the examples you see on that screen. Um, so here's a really simple example. Well, if you made all of the numbers 2 apart, like these numbers here, if the space between each of the numbers is 2, and then in your second set of numbers the space between each number is 4. So if you're going up by 4 at a time, then your second set of numbers would have more spread, because a number set in which the numbers are 4 apart has more spread than a set of numbers in which the numbers are 2 apart. But you don't have to make the numbers equally spaced. For example, let's say these x's are my numbers. If these two numbers are 1 apart, and I make these numbers 2 apart, and then these ones 1 apart, and then these ones 2 apart, and then that's my first set of numbers. And for the second set of numbers, if I make these two numbers 2 apart, these ones 3 apart, these ones 3 apart, and these ones 4 apart, let's see what happens when we add up the spacing between the numbers. 1 plus 2 plus 1 plus 2 equals 6. So when you add up all of the gaps between the numbers, you get 6. Down here, 2 plus 3 plus 3 plus 4 is, well, 5, 8, 12. The total of the gaps between the numbers comes out to 12. And notice how the total of all of the gaps comes out to a higher number here, that comes out to a lower number down here. That means that this set of numbers has more spread than this set of numbers, which is what I was asking for. So one way to make sure that your second set of numbers has more spread than your first set of numbers is to add up the gaps between the numbers that are next to each other, and then make sure that the total comes out to a bigger number in your second set of numbers and a smaller number in your first set of numbers, like it does here. So yeah, the numbers don't have to be equally spaced like they are in the example that I put on the PowerPoints. For question number 7, you have to find out which of your 2 sets of numbers from question 6 has a higher standard deviation. So you have to look back at the 2 sets of numbers that you wrote out for question 6 and decide which one of them would have the higher standard deviation. And to get the answer to this question, you just have to understand what type of a data set would have a larger standard deviation and what type of a data set would have a smaller standard deviation. So you don't have to do any calculations for this question. This is just a question on understanding the standard deviation. I also have some short essay questions in here. Um, if you need more space to write out your answers, then it's fine to just go and when you're in Word, just press Enter and move this down to give yourself more space. Or if you know that you'll need more space, then just press Enter and give yourself more space. I think that covers this entire assignment. Just send me an email if you have any questions. I'll upload this assignment pretty soon.